It's said quite often that the modern world runs on software, but modern software runs on integrations. An integration, conceptually, it's fairly simple. You've got a mechanism which allows data to go across a system boundary. But as soon as you double click on that, it starts to get a bit more complicated. You've got how do you authenticate both sides of the integration? What's the message channel? What's the message format? What's the maximum size? How do you handle errors? How do you handle retries? And a million other things that make integrations a lot more complex than they first look. And then if you start thinking about modern applications and the fact you're moving from potentially a monolithic application where most things sit within a single system boundary, and you're moving then to microservices where each service is a system boundary, and then potentially even to serverless where every function is a system boundary. That can be a lot of complexity. And today we're going to talk about a few ways AWS can help manage that complexity using managed services. So my name is Dave, I'm a Principal Partner Solution Architect here at AWS, and I focus on security partners and on startups. So that means I've got the privilege of talking or working with our amazing partner community pretty much every day. And that's made me realize two things. One, integrations are super important to building pretty much anything. And two, that a bit like security, if integrations are working well, no one's really that interested, but as soon as they go wrong, suddenly everyone's very interested. Now there are probably a few people in the audience who are working on like big monolithic applications, and I just want you to know that this talk is for you as well. Visual example, a little bit trite. Here is a very monolith, and a bit of perspective from another angle. Here's our third-party logging platform, our authentication system, our marketing automation platform. And one of the great things about modern application architectures is that these hidden implicit integrations are kind of brought out into the open, and it's easier to make better decisions. This is a fantastic quote from my colleague Gregor Hope. Gregor literally wrote the book on enterprise integration patterns. And what we're really saying here is that it's no longer enough for integrations to be essentially consequences of upstream software or architecture decisions. Integrations need to be front of mind and a first-class citizen in all of the design discussions that happen around your platform. And to try and make this point a bit more clearly, we're going to do some whiteboarding, hopefully. Okay, so if we can bring up the whiteboard when everyone's ready. Sorry about this, everyone. So what we can start by saying is that Unicorn Rentals, they've started out like a lot of companies do, pretty simple. They've built a simple monolithic application. It's a simple EC2 instance hosting an application. We've got two applications. We've got this is more complicated now. We've got the Rider application, and we've got the Unicorn application. We've got a simple load balancer. And then we've got our application here running on EC2, and we have a simple database. Apologies for the quality of the drawing. It's not much better with the pen actually, but it's fine. The riders can request a ride, the unicorns can accept a ride, and it's all managed by this single application. This has been working well. They've had a lot of growth. I mean, why not? Who wouldn't want to go to work on a unicorn? I know I would. So now they're looking at increasingly risky deployments, increasingly complex software, and inability to scale, which is causing them some real problems. So what they've started to do is break out some of the functionality of their platform into microservices. And we can see here a pretty common pattern. They've started out using services in ECS, Amazon Elastic Container Service, and they've split out three services: the routing engine, which essentially calculates the best route from A to B, the availability engine, which uses cool geospatial queries to find the closest available unicorn, and then an analytics platform to start down the journey of building some BI dashboards to understand and optimize the business. None of this is particularly strange. You might have heard this referred to as the strangler pattern. I think that came from one of my colleagues, Adrian Cockcroft, back in the day. And essentially decomposing the monolith by bringing parts of that functionality out into services that can then be independently scaled. And the question becomes, how do we start to connect these new services back to our monolith in a way which is scalable and manageable? And what a lot of companies start by doing is using essentially HTTP, so making synchronous API calls. These API calls will go essentially like this. We'd make a call there, we'd make a call here, we'd make a call here. And that's fine, and that'll work fine if you've got 3 services. But what about when you've got 30 or 300 or 3,000 services? This can quickly become unwieldy. And all the things we talked about, like the scaling, the authentication, the error handling, all has to be done in code at both sides for each one of these integrations. And what often happens is you end up with some anti-patterns, like either microservices sharing databases or microservices calling microservices in a synchronous fashion, which can lead to a really fragile product. And none of that's ideal. So what is a better way of doing this? I'm going to start with, I'm going to start with our first service of the day, which you may have come across before, and that is Amazon's Simple Queue Service, or SQS. And what SQS is, basically, is a cloud-native, highly scalable messaging platform that allows one or more producers, which I'll put here on the left, to connect to a single consumer or a fleet of consumers. I'll come back to that in a second. The queue sits in the middle here, and then we produce onto the queue and we consume off the queue. This is a asynchronous messaging, and it's pull-based. So the consumer is pulling messages from the queue whenever it's ready and new messages are there. Now, this gives us a bit of flexibility in terms of the producer side. We can have multiple producers. Each of these producers can put their own messages onto the queue. Let's just get some different colors here for clarity. So a message here and a message here. And this then allows us to pass these messages through to our service on the right. Now, it's important to note that all the consumers here have to be the same type of service, because we're not load balancing here, we're not splitting that message out. Each message is only going to be sent once. So if you've got 2 different consumers, they'll each get a subset of the messages. But what this allows us to do immediately is gives us decoupling from left to right. Essentially, because it's asynchronous, there's no longer a direct dependency between the 2 systems. Furthermore, and this is going to be hard to draw with my fingers, I'm afraid, it gives us a couple of really useful properties. One is the idea of load smoothing. So what we'll have is let's say, our left and right here. On this side, we've got a very variable spiky workload. On the right-hand side, after SQS, we will have essentially a straight line, or at least a line that we know that side can cope with. So immediately that protects that workload from spikes, and it allows us to smooth that out. It also gives us load balancing, in that we can add additional consumers to this side without making any changes or managing any infrastructure such as a load balancer. So what would the service look like if we went with that model here? So we've got our SQS queues, and then for each of those, we're going to essentially produce messages from our application for each of the downstream services. Now that's good. That gives us a lot of what we need, but it doesn't solve all the problems. And if you look at what we've got here, we're still making changes to our monolith. And if we want to add a new service, let's say we add a new service down here, we add a new queue, we still need to make changes to our application here to send a new message, and that to be consumed by our queue downstream. So is there a better way to approach this? One thing we could think about is using our second service for today, which is Amazon Simple Notification Service, or Amazon SNS. SNS is again, cloud-native, highly scalable message broker, and this is a near real-time push-based model, and it's often referred to as a publisher-subscriber model. What we have here is essentially we have a one or many publishers. We have our SNS queue in the middle, or SNS topic, in the middle. And then we have multiple different services. So we might have 1, 2, 3. 3. And the difference here with the service we talked with SQS is that when we start to produce messages onto the topic, ooh, why aren't you working? Onto the topic. No, that's not going to work, is it? Oh, well, never mind. Not sure what's going on there. Sorry, everyone. Stupid pencil. Can you come back? No. All right. Anyway, when we start to produce messages onto that topic, what we'll see is each of the downstream services will get a copy of that message. And that allows us to easily scale because we now have strong decoupling between the publisher and the subscriber. And we can add or remove subscribers dynamically without making any changes to the publisher or any changes to the message format. So if we go back to our diagram up here, what we can see now is we've introduced that. So now our application is sending a single message to the notification service. That's then being forwarded to all of our services on the right. And that now means we can very easily add a new service by simply creating it here, connecting it to the topic with a subscription and giving it permissions to read from that topic. And as soon as that happens, it will start receiving all the messages the other three are receiving without any changes to our monolith at all. And that is valuable. But what we're losing now is some of the things we talked about before. We lose the load balancing and load smoothing. This is push-based. So every time we send a message, it will be immediately sent to the services on the right-hand side. So we may well still need to do things like introduce load balancers in front of our services to handle that increased traffic. And it can lead to situations where, for example, if we have a failure in the routing service, when it comes back up, it might be overwhelmed by a combination of normal traffic and retries. So we've solved some problems and created other ones. So what can we maybe do to think about solving that? And that comes to our first kind of complex integration pattern I'm going to talk about today. I'm not going to try and write it, but it's called topic queue chaining. And this is pretty much what it sounds like. What we're going to do is we're going to get a SNS topic. We're going to make a SQS queue here. And then we're going to subscribe the queue to that topic. Now, what does this give us? Well, immediately we can see that we're using two services rather than one, which maybe not be ideal. But in terms of the behaviors we're getting here, we can now get a lot of the behaviors we wanted from both of these systems. So let's say we have a single producer over on this side, and we're going to have three consumers here. Here we have a red one. Actually, let's have two. It's even easier. So a red one and a blue one. What we can do is with our consumer, we can send a single message to our topic. That topic can then be sent automatically. Oh dear me. Come on. Why you no work? To multiple queues. So essentially we're sending that out to two queues, and then we subscribe to those queues from our two services. So that means that we can have the load smoothing and the load balancing from SQS. We can have the strong decoupling and the scale out to multiple services from SNS. And we get it all in the infrastructure without writing a single line of code. Now, on top of that, we're also getting other things. We're getting retries, we're getting exponential backoff, we're getting strong authentication of the service. We're getting dead letter queues, so if a message can't be processed, it will be essentially put into a separate queue which can be processed by another service or looked at manually for errors. So all these things that you might need to build into your software are being done at the application layer, at the infrastructure layer instead. So what does that look like over here? So you see now we've got our topic and our multiple queues. If we want to add a new service, we add a new queue, we add a new service, and it automatically will start getting the messages and enable us to keep working. This reduces the number of changes required on the monolith, and it also gives us all of the benefits from both of those services when it comes to workload protection and scaling and what's the word? Resilience. So this is good. Now I want to talk a bit about a couple of other things that might be useful to you depending on what you're trying to build. So I want to talk about a couple of topics. One is fairness and the other one is idempotency. Now for fairness, it's fairly straightforward. If I've just come out of a gig, it's raining, I'm soaking wet, I click my button saying I want a unicorn, I want to make sure that my place in the queue reflects when I pressed it, and the guy next to me doesn't get his unicorn first. So, and fairness is important in both ways as well. If I'm a unicorn and I want to click accept a ride, I want to make sure that I get that ride and not someone who clicks it after me. So the way we can build fairness is with ordering. Now, you can build ordering into your application by looking at things like timestamps, looking at message IDs, and that, it'll work, but it's hard, and you have to do it for every integration. So why not let the infrastructure do it for you? With SQS and SNS, you can use what's called FIFO, or first in, first out mode. This is going to be really hard to draw without the pencil, but I'll give it a shot. So we have our producer, and we have our consumer over here. Now, and we have, let's say, we have SQS here, so that's a queue. Now, when we do this in normal mode, there's a chance that we will get different behaviors, and that's because of the nature of these highly scalable systems like SQS and SNS. That we might get the message delivered more than once, and that's called at least once delivery. And we also might get them out of order. So if we have message 1, 2, 3 here, what we might get over here is 2, 3, 1, 1 on the other side. If we enable FIFO, we get strong ordering. So you'll get 1, 2, 3 on the left, 1, 2, 3 on the right. And that's a super easy thing to turn on, which can then save you a lot of time building it in the code. Similarly, idempotency, or the ability to process a message more than once, can be quite hard. When you think about, let's say, a simple function where you are either setting a variable to a number or you are incrementing a value. So let's say we've got a function x equals 3, and we've got a function x equals x plus 3. Now, if I run that first equation 10 times, x will still be 3, and that is idempotent. If I run the second one 10 times, x will be 30, or 30 higher than it was at the start, and that is bad if you're doing things like taking payments. If someone is trying to give me some money, I want to make sure I get paid, but I want to make sure I only take that payment once. And with ordered queues using FIFO, you can then enable data deduplication inside the queue or topic, which will essentially look at a 5-minute sliding window and will remove any duplicates in that inside that window. That means you're not then looking at timestamps or message IDs or anything else to try and identify duplicates in the queue. And that can give you that strong idempotency of the service without needing to build that into your code. So these are two other features you can get in your infrastructure by enabling features of SQS and SNS. So with all that in mind, I want to go to our final complex integration pattern for the session, and that is this idea of scatter gather. Now, the more observant people here may have noticed that all the arrows in this diagram point to the right. So we are sending a message out, and then we're never getting a return value. And that is actually probably okay for the analytics platform. That's going into a separate database. But for things like your routing and for your availability and other services like pricing, for example, you need to get that information back into your monolith and then eventually back into a ride order for a unicorn and customer. So what we've got here is we've got the first half of the scatter gather or fan out, fan in pattern, where we've got a single message going out to multiple places for concurrent processing. What we need to do next is add the gather phase. In the interest of time, I'm going to go straight to the place where I've already written this. And what we can do here is you can use a queue, an SQS queue, to essentially gather all of the results back and then push those into your monolith or potentially into another application if you were even more risk averse on the monolith side. Now, there's a key thing to remember here. You need a correlation ID. This is absolutely critical. You need to put something into your request, into your JSON blob or whatever you're sending, which identifies the initial request from a rider or the acceptance from a unicorn or whatever is happening there. So when these are gathered back in at the end, you know this route, this availability response, this pricing response relate to this request from this user. And so without that, obviously none of this works. There are some other patterns you can use, and I do see these, which are Yeah, they work, but again, at scale, I think they're not really effective. We see a lot of people using direct database access, where essentially your services on the right are writing back into that central database. The problem there is that introduces coupling again, because each of those services needs to understand the database schema, and if that schema changes, all of those services need to change, potentially. And the other thing is it can introduce performance issues, locking, issues with transactions. So that's not really ideal. Similarly, if you are using something like a webhook, you could expose a HTTP endpoint on your monolith and have things call back into that. But what you're doing there is you're immediately pegging the availability of the entire service to the availability of that webhook. And again, introducing all of the same potential scaling performance issues that we're trying to get away from by building this in the first place. So and I think this is probably a really great place to start. Clearly this is a small example, but we have customers with hundreds, thousands, maybe even tens of thousands of microservices. And using these patterns allows you to really tame that complexity and stop it from overwhelming you, any benefits you get from moving to a microservices or a serverless architecture. I'm going to mention very briefly one more service, which is Amazon Event Bridge. So Amazon Event Bridge, again, it's a highly scalable message bus, and what this gives you is, instead of something like SNS where you have basic routing and filtering options, this gives you advanced routing and filtering, so you can essentially decide which subscriber gets a message. That allows you to build more complex and more efficient applications. It also allows you to do things like transformation, so you can actually make changes to messages before they're sent to certain downstream systems, which again means you can take a single message from your producer and then use it in multiple ways with multiple different consumers. And the final thing which EventBridge gives, which is probably actually the single biggest benefit, is it gives you the ability to take the schemas that are used in your messages, store them in a persistent registry. That registry can then be used to generate code bindings and do validation of messages. So if I'm making a new service over here on the right hand side, I can essentially go and look at the schema of all the messages I expect to receive and then generate code bindings directly in my IDE to consume those messages, again speeding up the development of new services, improving agility and improving the consistency of data. So I'm coming close to the end now. I know it's not the most exciting of subjects, but hopefully there's a few things here which will be useful to you when you're building your next application or service. I've got a few key takeaways here. And the first one, the biggest one, be intentional when building integrations. They can be a massive differentiator for the way you build your application, and they can accelerate velocity. They can implement a lot of things which otherwise need expensive and time-consuming code to fix or to implement. If you choose the right service for the right job, we've got a number, not only the three we've mentioned today. We have data streaming services under the Kinesis brand. We have Amazon MQ, we have Kafka, managed streaming Kafka. There are so many ways you can do messaging and eventing in AWS. So understand the capabilities, map them to what you need, and choose the right service for the job. And finally, you can implement far more complex patterns in infrastructure by combining these services together. If you absolutely need the fan out, fan in pattern you can build with SNS or EventBridge, but you also want the load balancing and load smoothing, then combine the services and get both without writing code to do any of that. And that becomes even more important with more complex things like idempotency, ordering. So that's basically everything I've got for the whiteboard today. I'm hoping that we can go back to our slides. I need to move on there. If you want to learn more, you've probably seen this already today, if you want to learn more about AWS messaging services or pretty much any of our services, Skill Build It, you can join millions of people learning on AWS. We've got a 7-day free trial, and there are also a load of free courses on there as well. I'm on there pretty much every week. Now, we run these sessions for you. I mean, other than the feedback that my pencil should have worked, we would love to get some feedback on the session. It's the only way that we can get feedback and make the sessions better, more relevant, more impactful. You can download the application from the left-hand side, leave feedback for this session on the right, but also leave feedback for any sessions you attend. It's really important, and we would really appreciate if you took the time to do it. And if you've got any more questions about, there we go. Got any more questions, you're very welcome to reach out to me on email, find me on LinkedIn. Love to talk about this stuff, and thank you very much for your time and attention.